determine the left-sided limit and the right-sided limit and the two-sided limit as x goes to 1 of 3x squared minus 8x plus 5 over the absolute value of 1 minus x squared. Each of these limits involves the limit as x goes to 1 of 3x squared minus 8x plus 5 over the absolute value of 1 minus x squared. The first thing to do is try plugging a 1 in for each of the x's. That will give us 3 times 1 squared minus 8 times 1 plus 5 over the absolute value of 1 minus 1 squared. 1 squared is 1 times 3 will be a 3. A minus 8 times a 1 will be a minus 8, and then plus 5 all over the absolute value of 1 minus 1 squared, which is a 1. 3 minus 8 is a negative 5, plus 5 will be a 0 over the absolute value of 1 minus 1, which will be a 0. Since the limit resulted in a 0 within the absolute values, it is required to work out each side of the limit separately. So we will need to look at the limit as x approaches 1 from the left side, indicated by the negative superscript on the 1, and the limit as x approaches 1 from the right side, indicated by the positive superscript on the 1, separately from each other, each of these on the same expression, 3x squared minus 8x plus 5 over the absolute value of 1 minus x squared. So I'll write it down here for the right-sided limit as well. But let's start with the left-sided limit. The first thing we need to do is factor the trinomial quadratic in the numerator and the difference of squares in the denominator. So we will have limit as x approaches 1 from the left side of, in the numerator we have a 3x squared, so that'll factor into a 3x and an x. And we need two numbers that multiply to be a positive 5, but add to be a negative 8, where one of them is multiplied by a 3x, and one of them is multiplied by a 1x. And nicely, 5 has divisors of only 5 and 1, so we know it'll be a 5 and 1. One option is to put the 5 here and put the 1 here. And that will give us a 3x and a 5x, which can make an 8x. We need it to be a negative 8x, so they need to both be negative, and it looks like we have that factored. Now in the denominator we have the absolute value of what is a difference of squares. That'll factor into a 1 plus x and a 1 minus x. The next step, we will leave the numerator the way it is, but in the denominator we can break up the absolute value of the product into the product of absolute values. So it'll be the absolute value of 1 plus x times the absolute value of 1 minus x. And now we can analyze the limit according to the side that we're approaching from. For this one, we're the left side of 1. The left side of 1 on the number line is less positive than 1, like 0.99. And we're going to focus on the absolute value that makes the 0, and that's the 1 minus x as x goes to 1. That's making the 0 there. And if we plug in an x that is less positive than 1, like 0.99, and subtract it from 1, 1 minus 0.99, it will be a positive number. Since it's a positive number, the absolute value will not change it. It ensures that it stays a positive number by not changing at all. So we'll have our numerator here. But down in the denominator, we can remove the absolute value symbols around the 1 minus x. The 1 plus x will stay the way it is. We will replace the 1 minus x with parentheses and put a plus in front of the entire thing, because what was in there was already positive and the absolute value will not change it in any way. At this point we have the 0 over 0 indeterminate form, and we will continue to have that until we can cancel the factor, making the 0 over 0 indeterminate form. In the numerator that would be the x minus 1, in the denominator that'll be the 1 minus x. Those actually cannot cancel just yet. We need to factor the negative out of one of those. I will opt for the one in the numerator. The negative will be able to move to the front, so we'll have a negative of a 3x minus 5, and we're factoring the negative out of the x minus 1, so that'll make the 1 become a positive and the x become a negative. And the reason for doing that is to be able to cancel. In the denominator we have a positive, we have the absolute value of 1 plus x. We cannot change that absolute value since it's not making a 0 inside the absolute value. It's just going to stay in the absolute value symbols. But it's okay because it's not involved in making the 0 over 0. Only the 1 minus x is. And they can now cancel out. And that should remove the 0 over 0 indeterminate form. So let's just rewrite what we have left at this point. And we can now try plugging a 1 in for the remaining x's. That will give us a negative of 3 times 1 minus 5 all over the positive absolute value of 1 plus 1. So in the numerator we have the negative of 3 times 1, which is a 3, minus a 5, over the positive absolute value of 1 plus 1, which is a 2. So we have the negative of 3 minus 5, which is a negative 2, over the positive absolute value of 2 is a 2. The double negative in the numerator will give us a positive 2 over a positive 2, and they will cancel down to a positive 1. Now let's look at the right-sided limit. And it will follow a similar process at the beginning, the factoring. So it'll factor into a 3x minus 5 and an x minus 1 all over an absolute value of a 1 plus x and a 1 minus x for the difference of squares. And the next step, we can take the absolute value of a product and break it into a product of absolute values. So we'll have the 3x minus 5 and the x minus 1 in the numerator don't change. And we'll end up with the absolute value of 1 plus x times the absolute value of 1 minus x. And this is where we can analyze according to the side that we're coming from. We're now approaching 1 from the right side on the number line. The right side of 1 is more positive than 1. More positive than 1, like 1.01, plugged in for the absolute value that's making the 0 if x is a 1. If you plug in an x more positive than 1 there, 1 minus that, like 1.01, 1 minus 1.01 will be a negative number in the absolute value. Now the absolute value ensures that what comes out of there is a positive number. If what goes in is a negative number, the absolute value will take the negative of it. So we can remove the absolute value symbols from the 1 minus x by taking the negative of the result of 1 minus x in parentheses. I'll put the negative in front of the whole expression. Now the 1 plus x and the absolute value symbol has to stay because it's not making a 0. It's only the zeros and the absolute values where we analyze according to the side. So there's a negative because 1 minus x will be a negative. The double negative will make it positive again for the absolute value. We have the 0 over 0 indeterminate form here. Once again, we cannot cancel the factors because they're opposite sign of each other. So we will factor a negative 1 from the numerator. And that will change it to a positive 1 and a negative x. in which case it will be able to cancel with the 1 minus x in the denominator. So that's our next step, is to cancel those factors out. And while we're at it, the negatives can cancel as well. That and that can cancel. And we're left with the limit as x goes to 1 from the left side of 3x minus 5 over the absolute value of 1 plus x. And now that we no longer have the 0 over 0 indeterminate form, we can plug the 1 in for the remaining x's. So we'll have a 3 times a 1 minus 5 over the absolute value of 1 plus 1. 3 times 1 is 3 minus 5 over the absolute value of 1 plus 1, which is a 2. 3 minus 5 is a negative 2. The absolute value 2 is a positive 2. A negative 2 over a positive 2 comes out to a negative 1. For the two-sided limit, we compare the results of the one-sided limits. They are different from each other. So back up here, the two-sided limit will be does not exist. And there's the results of the three different limits.